Sample problem 4.06. What is the magnitude of the acceleration in g units of a pilot whose aircraft enter a horizontal circular turn with a velocity of vi vector equal to 400 I cap plus 500 j cap meter per second, and 24 seconds later leaves the turn with the final velocity vf vector equal to minus 400 I cap minus 500 j cap meter per second. So in this question, a pilot who takes his aircraft and he enters the horizontal circular turn. So let's draw the diagram. So this is the horizontal circular turn, and he entered the horizontal circular turn with the initial velocity vector. So vi vector, which is equal to 400 I cap plus 500 j cap, and the unit is meter per second. So he takes the uniformly circular turn with the initial velocity. So let's we take, he just moves in this direction with the initial vector. Clear? And then after 24 seconds later, he leaves the turn with the final velocity vector of minus 400 I cap minus 500 j cap meter per second. That means you can see the magnitude of the initial velocity and the final velocity will be the same. So that means he just moves in the opposite direction after 24 seconds. That means for going and coming back, what's the total time? For going and coming back, he took 24 seconds for entering a turn and 24 seconds for leaving the turn. So 24 seconds plus 24 seconds. So totally he took a 48 seconds for going and coming back on the same horizontal circular turn. And also you can see the initial velocity and the final velocity, it has the same value of I cap and j cap, only the sign changes. That means the final, it takes the opposite direction. So now by using this, we have to find the acceleration. So what we studied in the theory, we already studied the formula for a centripetal acceleration as well as the time period, right? So let's rewrite the two formulas. So what's the formula for a centripetal acceleration? So centripetal acceleration, which is equal to v square divided by r, and the time period t equal to 2 pi r divided by velocity, right? Now we are going to find the acceleration because we have to give the answer of acceleration in g unit. So first we find the acceleration, then we will convert that acceleration in g units. Clear? So what I have to do, I have to use these two equations for finding the answer for centripetal acceleration. But the most important thing, if you just see these two equations, so let's we take, this is our equation 1, we'll take this one is equation number 2. Now I'm going to rearrange equation 2. Rearrange equation 2 in terms of r. So we are going to rearrange this equation 2 in terms of radius r. So if you rearrange in terms of radius r, what you will get? So we have to rearrange this equation in terms of radius r. So therefore r equal to t multiplied by v divided by 2 pi, right? So let's we take this equation is 3. Now what I'm going to do, I'm going to substitute equation 3 in equation 1. By that we can easily get the acceleration. So why we made this change? Because the radius of the circular turn is not given. That's the reason we modified the equation 2 in terms of radius, and then we substitute the radius equation in the centripetal acceleration. By that we can easily find the answer for the centripetal acceleration value. Clear? And later on, after that, we have to convert that in terms of g unit. So now let's we substitute equation 3 in equation 1. So what you will get? So let's we write the equation 1 first. So a equal to v square over r, and then we have to take this value of r, and I'm going to substitute here. So by that, what you will get? A equal to v square divided by tv over 2 pi, and this 2 pi will go to the top. So by that your acceleration equation becomes v square multiplied by 2 pi divided by a tv. So we can cancel v and v in the top and bottom. By that we will get the equation as a 2 pi v divided by t, right? Now I'm going to substitute the value. So for this v, we can take the magnitude of the initial and the final. So that's up to you, because if you take the magnitude of initial velocity and the final velocity, we will get the same answer. Clear? So I have to find the velocity magnitude. So let's we take any one of the equation. So by that we can easily find the magnitude of the velocity, because we have to substitute the velocity magnitude here. So for finding the velocity magnitude, what we have to do? Let's we take one equation. So 400 I cap plus 500 j cap. When you take the magnitude, what you will get? So this is magnitude, right? So you will get 400 square plus 500 square, which is equal to, let's see what's the answer. 400 square plus 500 square. I got the answer here, 640.31. 640.31 meter per second. If you want to use the final velocity, you will get the same answer. So you can use any one of the equation. So now I have to substitute the value a equal to 2 pi multiplied by 640.31 divided by the time period, because we said 24 plus 24, which is a 48 second. And now once you just solve this part, you get the answer for the acceleration in meter per second square. So therefore acceleration, which is equal to 2 multiplied by pi multiplied by 640.31 divided by 48. I got the answer here as 83.82. 83.82 meter per second square. But what they ask in this question, we have to give the acceleration in g unit. So how we can give the answer of acceleration in g unit? It's very easy. When you divide this acceleration by 9.8, we can give the acceleration in g unit. So let's we give the answer of acceleration in g unit. So what we have to do? We have to divide this number by 9.8. So therefore 83.82 divided by 9.8. So let's we see what's the answer. 83.82 divided by 9.8. We got the answer here as 8.55 g. That means it's a g unit. So the answer for the acceleration here is 8.55 g. So this is the answer for this question. Here it's point. Okay, so 8.55 g. Thank you.